In an electrical installation within a wood building, where metal boxes are used for receptacles and switches, and metal conduit serves as the raceway, understanding proper grounding and bonding is crucial. Even with a wiring configuration including one hot wire, one neutral wire, and a ground wire, and even when connecting the ground wire to the receptacle's ground screw, and even when the receptacle has a spring in the yoke for flush mounting, it is still necessary to bond the metal box with a wire and screw. The ground screw in the receptacle is not sufficient for bonding the metal box to the grounding system effectively and safely. The National Electrical Code, or NEC, mandates that all metal boxes must be bonded to the grounding system. This requirement is in place because metal boxes can become energized if there is a fault in the wiring. Bonding the box to the grounding system ensures that any fault current is safely conducted away from the box, thereby preventing electrical shock hazards. The reason the ground screw in the receptacle is inadequate for bonding the box lies in the fact that it does not provide a reliable electrical connection for fault currents. The spring in the yoke, while it may seem to provide a good connection, can become loose over time due to vibrations, corrosion, or other factors. This loosening can break the connection between the ground screw and the box, leading to a situation where the box is not properly bonded. Such a scenario can create a dangerous situation, especially if a fault occurs. To properly bond the metal box, several steps need to be followed. Firstly, use a green or bare copper wire that is at least number 12 American wire gauge, or AUG. This size is typically sufficient for most residential and light commercial applications, but it's always best to consult local codes or a qualified electrician to ensure compliance with specific requirements. Secondly, connect one end of the grounding wire to the ground screw inside the metal box. This screw is typically located at the back of the box and is often marked with a green color or a grounding symbol. Thirdly, securely tighten the screw to ensure a good electrical connection. A loose connection can impede the flow of fault current and render the bonding ineffective. Fourthly, run the other end of the grounding wire to a grounding electrode. The grounding electrode can be a metal water pipe, a metal conduit, or a ground rod. If using a metal water pipe, ensure that it is in direct contact with the earth for at least 10 feet. If using a metal conduit, ensure that it is properly grounded back to the main electrical panel. If using a ground rod, it should be at least 8 feet long and driven into the ground. Fifthly, ensure the grounding electrode is properly connected. For a metal water pipe, use a grounding clamp to securely attach the grounding wire to the pipe. For a metal conduit, use a grounding bushing and jumper wire to connect the conduit to the grounding system. For a ground rod, use a grounding clamp to attach the grounding wire to the rod. Sixthly, after the box is properly bonded, it becomes safe to connect the receptacle to the box. The ground screw in the receptacle is then used to connect the receptacle to the grounding system, providing an additional layer of protection. The grounding system works by providing a low impedance path for fault current to flow back to the source. This low impedance path allows the fault current to quickly trip a circuit breaker or blow a fuse, cutting off the power to the circuit and preventing electrical shock. The effectiveness of the grounding system depends on the quality of the connections. All connections must be clean, tight, and free of corrosion. Regular inspections of the grounding system are recommended to ensure that all connections are still in good condition. Several types of grounding and bonding equipment are available. Grounding bushings are used to connect metal conduit to metal boxes or enclosures. They provide a smooth, low impedance path for fault current to flow between the conduit and the box. Grounding lock nuts are used to secure metal conduit to metal boxes or enclosures. They have a sharp edge that bites into the metal, providing a good electrical connection. Grounding clamps are used to connect grounding wires to metal water pipes, metal conduit, or ground rods. They are available in a variety of sizes and styles to accommodate different types of grounding electrodes. Grounding screws are used to connect grounding wires to metal boxes or enclosures. They are typically made of brass or copper and have a green finish. When installing electrical wiring, it is important to follow all applicable codes and regulations. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems. Local codes may also have additional requirements. It is always best to consult a qualified electrician if you have any questions about grounding and bonding. Several common mistakes can compromise the effectiveness of the grounding system. Firstly, failing to bond metal boxes to the grounding system. This is a common mistake, especially in older homes. Secondly, using the wrong size grounding wire. The size of the grounding wire must be adequate to carry the fault current. Thirdly, making loose or corroded connections. Loose or corroded connections can impede the flow of fault current and render the grounding system ineffective. Fourthly, failing to properly ground metal water pipes, metal conduit, or ground rods. These grounding electrodes must be properly grounded to provide a low impedance path for fault current to flow back to the source. In addition to the NEC requirements, there are other best practices that can improve the safety of electrical systems. One best practice is to use ground fault circuit interrupters, or GFCIs, in all wet locations such as bathrooms, kitchens, and outdoors. GFCIs are designed to detect even small amounts of leakage current and trip the circuit, preventing electrical shock. Another best practice is to use arc fault circuit interrupters, or RSIs, in all branch circuits that serve bedrooms. RSIs are designed to detect arc faults, which are a common cause of electrical fires. By following these best practices, it is possible to create electrical systems that are safe and reliable. In summary, bonding metal electrical boxes is a critical safety measure that must be performed even when the receptacle has a grounding screw and a spring yoke. The NEC requires that all metal boxes be bonded to the grounding system to ensure that fault current is safely conducted away from the box. To properly bond the box, use a green or bare copper wire of at least number 12 AWG, connect it to the ground screw in the box, and connect the other end to a grounding electrode. Always follow applicable codes and regulations and consult a qualified electrician if you have any questions. This ensures the safety and reliability of the electrical system. Remember to regularly inspect your electrical system.